Alright guys, so for 10.4, we're going to be talking about comparing populations. Now we compare populations by using what is called a box plot. You have probably seen these before. So if we read through this, a box plot uses a number line to show the distribution of a set of data. It divides the set of data into four parts using the median and quartiles. A box is drawn around the quartile values, and whiskers extend from each quartile to the minimum and maximum values that are not outliers. So watch for outliers, we don't want to include them. Then a double box plot consists of two box plots graphed on the same number line, and you can draw inferences about the two populations in a double box plot by comparing their centers and variability. So before we start comparing our populations using our double box plot, we want to talk about all the different pieces of the box plot. So looking at the left here, this whisker here shows the lowest value. So that is our minimum. Then moving to the right, this first line we see shows our lower quartile, which we typically just label Q1 for quartile 1. The line in the middle, that's nothing new, that's our median. Now you might also see that referred to as Q2, but we would typically say the median. And our line on the right, the left is the lower quartile, and the right is the upper quartile, which we typically label as Q3. And then the whisker on the right shows the highest value, which we normally label as our maximum. So minimum, Q1, median, Q3, maximum. Now the width of our box here, so from line to line, from Q1 to Q3, shows our interquartile range, which we can just label as IQR, which we learned about in the last section. Now something else I want you to add on to here. Each of these quartiles, think a quarter is 25 cents. So they represent 25%, 25% for our upper quartile. And then each of these in the middle is also 25%. But from Q1 to the median to Q3 then would be 50%. So each quartile is 25%. And you're going to need to remember that in case if we would ask you what percent of the data lies below or above a given value. It's going to be 25, 50, 75, 100, or 0. So remember that they are all 25%. Okay, now that we have labeled our box and whisker box, we want to now start talking about comparing. So Casey surveyed a group of students in her science class and her math class. The double box plot shows the result for both classes. Compare their centers and variations. Write an inference you can draw about the two populations. Okay, so we see, using the same number line, we're starting at 0, ending at 30. So they both have the same overall variation. They both have a range of 30. So that doesn't tell us much. But if we look at our interquartile range, we'll notice our math class, if we draw down, goes from 5 to 20. So our IQR here is 15. Versus the science class, we go from 15 to 25. So our IQR here is only 10. So we can use that as an inference. I will also notice majority of the data for your science class is 15 or higher. 75% of the data is 15 or higher versus 10 or higher or 5 or higher for 75% for your math class. So overall, some inferences that we can draw from here are the people in science are more social based on, we're talking about how many of you have posted a blog in the last month. And we can say that because the box part, so that IQR is higher on the number line. So that's one inference we can make. Overall, the science class is more social, or they blog more often. We could say that the science class has a higher median. And then one last inference we can make here, I'll do this one in red. So in math, the data is more spread out. And we can say that based on a higher IQR. So that gives them a little more variance. Overall variance is the same. They both go from 0 to 30. But you notice again that the IQR for the math class is 5 higher than the science class. So that tells us that their data is a bit more spread out. So we're looking for inferences like that we can make based on the double box plot that's given. All right, we've got one last example in this lesson. So you may recall that a line plot is a way to organize and represent the data in a data set. Another name for a line plot is a dot plot. A dot plot uses dots to show frequency of data values in a distribution. A double dot plot consists of 2 dot plots that are drawn on the same number line, again using them to make some inferences or to compare a population. Okay, so the double dot plot below shows the daily high temperatures for 2 cities for 13 days. Compare the centers and variations of the 2 populations, and then write an inference you can draw about the 2 populations. So if we check out our range, again, using the numbers down here for both of them, we go from 78 to 84. So our range is 16. Versus down here, we're going from 81 to 87, so the range is still 16. So that tells us that they have the same variation of data. Oops, that should have been a T there. And again, that is based on the ranges. So same variation of data based on the range. But then if we want to make an actual inference, you'll notice that Lake City's numbers are all higher on our number line. So Lake City overall has higher temps or temperatures than Springfield. Okay, so again, this lesson was just about given the data, can you interpret it, tell me something about the data given the images, and make sure, this was a lot of vocab on the first slide, make sure that you can label each of these pieces here. How that's going to be test and quiz questions coming up, so given a blank box plot, can you label each piece? So your minimum, your Q1, median, Q3, maximum, and your IQR. All right, that is the end of this lesson.